Hi all, this is information about assignment 3, the real-time lab exam. This will take place on Wednesday the 10th of June at 9 AM and will close at 3 PM the same day. You will have the whole time to complete it, but it should only take you 1.5 hours to complete. So first we'll look at how you get a copy of your exam. So navigating to LMS, scrolling down to assignments, keep scrolling down until you reach assignment 3. You'll have this cover page here which we'll go through together, and then you'll see a sample, some sample solutions, a set of algorithms, the lab reference you've been using the entire semester, and then the files. Now you can see here that these files won't open until the day of the exam. On the day of the exam, you will click this, click either Bendigo or Bandura, then find your particular exam. Everyone will have different questions, so search through until you find yours. And mine's right at the end. Okay, so I'm going to save that, and then we'll open it up and have a look. So first thing you'll notice is that it'll have your name on it and it'll have your student number where it says sample. There's 40 marks total, okay? It has the information about when it opens and when it closes. There are no late submissions or extensions. Everything is automated. When it reaches 3 o'clock, the server will close, okay? And you will not have access after that. So make sure that you do submit by that time. If you send me an email, there's nothing I can actually do, okay? This is all handled by ICT, not by us. I recommend that you submit whatever you can do, working or not. Ideally compiling, but even if the logic doesn't work, get it to compile and at least we can try and award you some marks, okay? The files. So you're going to have access to a set of files, and these are just templates. Most of these are just main, okay? So with these, we'll have a look at how to get these right now. Okay, so what you're going to do is go into LATS CS5 using your PuTTY terminal or SSH through Mac, and you're going to change directory into your assignments directory, which you would have created in week 1. So you should have a directory called assignments, and inside of that you should have a directory called assignment 3. Okay, so we should be in the directory PS 2020 assignments assignment 3. Your folders might be different, but you get the point. Then what we're going to do is we're going to copy our files. Now the tilde is missing here. I'm sorry about that. There should be a tilde. I will fix that in your version. But we've got CSI lib, CSC1, PES, /students, /assign 3, then your student number, okay? So the example that I'm using is all ones, okay? There's no student with that in this subject. A star, then a space. Do not forget this space. Then a dot, okay? If you spelt it all correctly and press enter, you shouldn't see anything. If you did something incorrect, it will prompt you that you've done something incorrect, okay? So put your student number. This is just an example. So once you've done that, you should see 6 files, okay? So you should see 6 files, and if we go into Notepad++, we go into assignment 3, we should see those 6 files here. Now you'll notice that they have task 1 _ 7, task 2 _ 3, task 3 _ 9, task 4 _ 6, task 5 _ 4, and task 6 _ 6. Don't worry about the underscore number at the end. Make sure you leave it in, don't remove it. But we've got task 1, 2, 3, 4, 5, 6, and it'll have your student number there. Please do not rename these. Please leave them the names that they are. Okay. When you open them, you'll see something like this. Okay. It'll have main. It'll have some information at the top. It says do not remove this line. Please note these are missing the includes, so you will need to include standard IO for all of them, and you might need to include standard lib. Okay, so you need to include that. Most of them are empty. Some of them will have a little bit of code. Okay, but the majority of them are empty. Some of them might be slightly different, like this one here. Okay, so this one has argc and argv. Okay, so everyone will have their own templates. This ensures that everyone's file names are correct and they have the right student number, they're in the right format, and they have the right number here. Okay, this is going to be really important for us when we're marking you, so please don't change the file names. Okay, make sure that you get your version, not someone else's. If you do get someone else's, we cannot mark you. Okay. Alright, so now we'll keep looking through this document, and the next thing that it says is how to submit. So you are not submitting through LMS, you are submitting through Unix. Okay, so how you're going to submit, let's say you've developed your program, you've compiled it. Okay, so you've done, I don't know, cc 11111 task 1. So we'll do -1 XOR -0, and we will have task 1.7. Okay, so I've compiled it, I've done all that, I've tested it, I've run it a whole heap of times, and then I want to submit. Okay, now you have to submit for it to be marked. If you don't submit, then it won't be marked. Whatever's on the server at the end of 3 o'clock is what will be marked. Okay, so make sure that you check that it is on the server. So the way that you're going to do this is submit PES and then the C file name. So in my example, it's task1.7.c. Once I do that, I press enter and I'll get this warning here. I certify that this is my original work. I understand the work submitted must may be reproduced or communicates for purposes of detecting plagiarism. Do you agree that you are implicitly making this statement? If you agree to that, press yes. It'll now should say file was successfully submitted, and we can type verify, and you'll see that this file is here. Okay, this is another file from another example that I did ages ago. Okay, so this is how you submit. Now let's say you want to make some changes, you can resubmit that same file, okay, and it will just overwrite it. Okay, so you can submit as many times as you like, okay, and you can resubmit as many times as you like. So make sure that you verify and you do submit. We cannot accept a submission if it's not submitted. Okay, we cannot submit it afterwards because it's all being automated through the server. All right, constraints. So you need to use types correctly. You don't have to use comments, but I would recommend it. The code must be done using ANSI C. So we are not using C99, okay? You will lose marks if you do use C99 and it will be counted as not compiling. It must compile on latcs5.cs.latrobe.edu.au using GCC. Okay? Code submitted must compile, given the above definition, to be awarded any marks. You must not use goto or exit. Any use of will result in 0 for the question. You are only allowed to include the standard.io.h, the standard.lib.h, and the math.h header files. None other, or else you'll get 0 for the question as well. This is going to be important for us and also for you to get your marks back as quickly as possible. When you prompt to a user, okay, so for example, you want a value from the user or you want a list of values, you need to end it with a colon. Okay, so please enter a value, colon. So this would be in a printf, for example. Okay, so make sure you put that colon at the end of all your prompts. Okay. The formatting needs to be as specified, so if we tell you which formatting to use, for example, if we say it needs to be left justified or it needs to be to 3 decimal places, you need to do that. You can decide on the text of the user, but it needs to be easily understandable. So, for example, here, you might just want to write, give me a value. Okay, we understand it. Okay, you can write whatever you like, as long as it ends with a colon and we understand what you're talking about. Academic integrity, okay. Plagiarism is somebody else's work, okay. For individuals' assignments, plagiarism includes the case where 2 or more students work collaboratively on an assignment. School of Engineering Mathematics treats plagiarism very seriously. When it is detected, penalties are strictly imposed. You've done the AIM module, and you can also look up academic integrity Latrobe, and there's a lot of resources there if you're unsure what that means. Now, the resources that you should try and use. This is open book and you can use whatever you like, but everything has been covered in the labs and everything's been covered in the lab videos, labs and assignments. Okay, so you don't really need any other resources and your best answers are going to come from them. So the first resource that I would highly recommend is the lab reference guide. A lot of stuff that's in this test comes from the lab reference guide. So make sure you know how to read them. This page especially is going to be very important. The format specifiers and the formatting. The other one that's going to help you is the algorithm guide. So in some questions you might need an algorithm. So we've provided a guide here, okay? One for summing, one for product, one for mean, one for max, and one for min. Now you'll notice that max and min are not the way we did it in the lab, okay? Because in the lab we had a sorting function. In the assignment in assignment 3, you won't have a sorting function, so you have to do it this way. I would highly recommend that you try and implement all 5 of these as practice for this test. All right. This is a completely individual assignment. You can ask for clarification on questions or submitting. So if something doesn't make sense, you can ask a question through Slack. Okay, you can DM me through Slack during the test and I'll be happy to clarify any questions, but you cannot ask for help on any of the implementation. That means if you've got errors, if you can't compile, if you can't solve the logic, you cannot ask. Submit what you know so we can have a look at what you know and try and focus on those things before the final exam. Okay, so be honest with your solutions, make sure you submit what you know, not what someone else knows, and show us your abilities in this test. Okay, so if you can't solve it, just submit what you can. Alright, if we continue from here, we'll find the questions. So you'll have a question here, okay, and it will tell you what you need to do, and then you've got your rubric here. Your I think I accidentally deleted the question text, but you've got the second question here, got the third question, got the fourth question, the fifth question, and you've got the sixth question. Now, in terms of what is covered in each question and what you need to know. So the first question is the first couple of weeks, and it's mostly about being able to read the lab reference sheet, knowing which format specifiers to use and how to use printf and scanf correctly. It also requires you to understand literals in different bases. Okay, so that literals in different bases video is going to be really helpful for this. The second task will probably be the hardest task for most people because we didn't spend as much time on it, but this is going to be based on bit manipulation and bitwise operators. So to study for this, I would highly recommend you look at the bitwise and bit manipulation videos and re-look at the bitlock application we did in the lab. And yeah, so that's what this one will definitely be about. This question 3 will be about functions. Okay, you will have to write and implement a function. Okay, this we've done a lot of. I don't think you should have too many troubles, but there's quite a few videos on functions there. The fourth task will involve arrays. These are not dynamic arrays, so static arrays. Okay, so these are the easier arrays, so no malloc or anything like that. And these ones will be based on arrays and algorithms. Okay, so this is where that algorithm sheet may come in handy. Some students it may be useful, some students it may not be. It depends on what question you get. Okay, but this is where the algorithms comes in, is being able to use an array and do an algorithm with it. Question 5 will be box and pointer diagram, and you will need to implement it. There's no output or input to this question, so you can ignore the unused variable warnings if you get them. Okay. The last question will be based on the last, so week 9, 10, 11. There's no question on week 12, so you don't have to worry about that lab. So this will be around malloc, files, and dynamic memory. So this one covers some of the more advanced topics, but there is only one question. Please also be aware that they are not all worth the same, so this one's worth 13, this one's worth 7, 6, 4, and 4, and 4. I wish you luck on this test. If there's any other questions beforehand, let me know. Keep an eye on the announcements, and if I think of anything else, I will put that there. Good luck, and I look forward to seeing what you're able to produce. Thank you.